So a couple of notes. The first, the difference between a sequence and a series, I think you've heard that before, is that a sequence is just a list of numbers and a series is separated by addition. And then recall last week, the formula for finding the sum of a finite arithmetic sequence is right there, just so you have it on paper. And then this week, the formula for finding the sum of the first n terms of a geometric series with common ratio r is not 1 is given by this formula. So S just means the summation of the first n terms, which means I need to know the first term a sub 1, I need to know r, the common ratio, and I need to know n, the number of terms. So if I can find those three things, I can find the summation without having to actually plug in a 1, plug in a 2, plug in a 3, all the way up to 10, and then have to add all of them up together. I can use this formula. So recall the format of this geometric series. It's a sub 1 times r to the n minus 1. So when I look at this problem with the 4 and the 3, and it's a k in this case, but it doesn't make a difference, this is of the format a sub 1 times r to the n minus 1, or in this case, k. So the number that they have plugged in for a sub 1 is 4. The number that they have plugged in for r is 3. And then n is the number of terms. And so if I go from 1 to 10, well, a 1 term, a 2 term, a 3 term, up to 10, that's a total of 10 terms. So I am going to use this new summation formula to find the sum of the first 10 terms, which is 4 times 1 minus 3 to the 10th all over 1 minus 3. So I have to do that exponent first, and then the numerator divided by the denominator. So I'm going to take 3 to the 10th and get 59,049. So 1 minus that divided by negative 2. So what I get in the parentheses is 29,524. And when I multiply that by 4, I get 118,096. So the summation of the first 10 terms is that big number. So we can find sums of finite series, meaning you're only adding a certain number of terms, in our case 10. If I asked you to find the summation of the first 20 terms, it would be an even bigger number, or the first 50 terms, it would be an even bigger number. So the idea of the sum of an infinite series is a topic of calculus, which means what if we add together all the terms in a series, all infinitely many terms in the series? And we're not really going to explore that in a whole lot of detail, but we are going to talk about the difference between a series that is convergent or divergent. And so a convergent series means that if I added up all infinitely number of terms, all infinitely many number of terms, it's going to add up to a number. So if you take 1/2 plus 1/4 plus 1/8 plus 1/16, it's going to converge towards a number. And we in this class are not going to talk about what it converges to. We're just going to recognize that it converges. It equals to a number. And that happens if the common ratio is, the absolute value of the common ratio is less than 1. And then a series is said to diverge, or is a divergent series, if the infinite sum of the series is infinity. So this up here would be an example of that case. If I have so many terms, it's just going to get bigger and bigger and bigger and bigger, the number that it's approaching, so it would be infinity. So it says, tell whether each series is convergent, will converge or diverge. So with divergent, the idea is that the absolute value of the ratio is greater than or equal to 1. So Lagrange should technically have a plus sign between here. 3 plus 12 plus 48 plus 192. If I continued that series and I continue to add terms, it is going to just get bigger and bigger and bigger. So also, what is the common ratio? The fact that the common ratio is 4 means that the series is going to be divergent, or it will diverge, because our absolute value of 4 is greater than or equal to 1. If you add up all of the terms in that series, it's going to be infinity. Letter B, so n equals 1 to infinity, that means an infinite series, and so again, I have to analyze what I'm given here. If this is in the format a sub 1 times r to the n minus 1, the number that's representing r is 2/3. And since 2/3, the absolute value of 2/3 is less than 1, this will converge. And I don't know what it will converge towards, that's not what we're doing in this class. It's just going to converge towards a number. And then letter C, just before you get to